All right, guys, so we're going to do systems of inequalities today. It's just like systems of equations, except they're inequalities, which means dashed and solid lines and some shading. And finding the solutions is a little bit interesting. It's the same basic idea, but with some twists. So we're going to go through this process. So the first thing we want to ask ourselves is, can I graph the lines as is the way that these are written? No. So we need to put them in slope-intercept form. So I'm going to take the first one down here and rewrite it just so I have room to write. And then how do we solve for y? What's the process? Okay, so subtract 2x, good, from both sides. That gets rid of it on the left side. We have this on the right side. And then we'll have 3y is greater than or equal to, and if you're doing true slope-intercept form, you'll put the negative 2x first plus 6. You wouldn't necessarily have to. Remember, if you can keep track of the slope, you could do it the other way. All right, so now what do I do? Divide by 3. Very good. So I'm going to divide everything by 3, rewrite it. So I have y is greater than or equal to negative 2/3 x plus, what would that number be? 2. Very good. All right, so the symbol, the greater than or equal to symbol, tells me two things about the line. What does the greater than part tell me? What does this greater than part tell me? Which side are we going to shade? Oh, so this tells us a solid line. What does this part tell me? Up. We're going to shade up. So when we do our line, we know we're going to do a solid line, and we're going to shade up. I'm already recording for you and recording, yeah. All right, so where do I start my line? Up to, am I on the x-axis or the y-axis?
Y.
Good job. So we start at point at 2. And then what do I do after that?
Down to right 3.
Okay, so we use the slope. We've done lots of lines this year, down 2 and right 3. As far as we can go, kind of carry it out to the edge of our graph because we don't know where these are going to cross. So I could also reverse, go up 2 and back 3 just like we did when we did our lines unit. You can kind of do another point out here. And we already said that this symbol told us we're going to do a solid line because we have the equal to. So we'll go ahead and use our rulers, make a nice straight line. And don't forget your arrows because that line goes forever. Okay, so the equal to bar underneath here told us to make the solid line. What did the greater than symbol tell us? We're going to shade above the line, and we'll test that here in a little bit, but that's just a little shortcut that we talked about because that's where the y values are going to be bigger than what's on the line would be above. And so pick a color to shade lightly. Don't take all day coloring. We're just going to shade everything up here. So in theory, if we've shaded the correct side, everything up there is a solution. And the points on the line are a solution. And we'll talk about testing points here in a second. We did them with the previous lesson. We're going to check some of these down here in a second. So we've rearranged this one, we graphed it, we did all of that. We got to do the second one. So there's going to be 2 on the same graph, just like we did with systems of equations. There's going to be 2 of these. They're going to overlap. The coloring is going to overlap. So we'll copy this one down over here. X minus 2y is less than 2. So talk me through this. How do we solve for y?
Subtract x.
Subtract x from both sides. Good. Gets rid of this. So then what do I bring down?
Negative 2y.
Negative 2y. Then what?
2 is greater than negative.
Oh, it's less than. So less than.
No, negative 2y is greater than. No, 2, never mind.
Negative x plus 2.
Negative x plus 2. I think you're a step ahead of me.
Yeah.
Because when we divide by the negative 2, what were you thinking was going to happen? It switches because we divided by a negative. Good job. So this flips. It goes, phoop. Like to have the sound effect. Okay. Phoop. And then, oh my gosh, we have to figure out what the slope is. So first of all, there's a negative in front of the x. What number is that?
1.
Negative 1. So we have negative 1 on the top, negative 2 on the bottom. What's my slope going to be?
2x.
No.
1 over 2.
1 over 2. Positive 1 over 2x. Good. And then I have 2 divided by negative 2, so y-intercept would be
Negative 4.
negative, I think you multiplied instead of divided. 1. It's okay. Negative 2 divided by negative 2 is negative 1. Okay, so we know this is going to tell us where to put the line. What does this greater than symbol tell us? Is it going to be a dashed or solid line? Dashed. And are we going to shade above the line or below the line? Yes. Above, because we're looking for y's that are greater than. So those are the two things that we're getting out of this. So where do I start the line?
1.
Negative 1 down here. Good. And then our slope is 1/2. So what does that tell us? Up 1, right 2, up 1, right 2. So we can put a couple points this way, and then we can reverse and go back this way if we want to get a few more points. And remember that we said it was going to be a dashed line. So we talked about an easy way to do that with the ruler is just to make just pick up the pencil. And then we still have arrows on the ends because that line goes on forever. So we talked about in the last lesson, when we do the dashed line, this is where all the points would be that would be equal to if there were an equal to bar. We make it dashed because it doesn't actually count. The points on that line are not actually solutions. Our solutions are only where it's greater than, and where did we say we were shading that? Up. So we're going from the line up. So we're going to shade this a different color. Although I have seen some people use the same color very effectively and just make it dark where it overlaps. You could do that as well. You can actually just use a pencil. That's what we did back in the old days. And then, so since this is a system of inequalities, instead of just having one solution region, we had two that overlaps. And so this part up here is where our solution lies. If you can write that over the top of your coloring, you can write it or write it to the side and draw a little arrow. So this is the solution to both of those inequalities, okay, is up in here. And so we talked about test points when we originally did the inequalities, and we talked about, okay, we have the shortcut where we can do up and down, but to be really sure, you do a test point. And so I have a list of points down here that we're going to check and see if they're part of the solution. And we're going to do this a couple of ways. First, we're going to see if it's in this part that's shaded with both colors. And then we're going to plug them in and see if they work for both the inequalities. So kind of a double check. So let's start with A, 2, negative 3. So if we start from the origin that's right, 2, down 3. Do you think that's going to be part of the solution?
No.
No, it's not on the shaded part. We could also test that by putting that into our inequalities. So I'm going to put, we have all this room down here on our notebook paper. Let's put part A and put that into our first inequality. So we've got 2x plus 3y is greater than or equal to 6. So 2 would go in for x, negative 3 goes in for y. So it'd be 2 times 2 plus 3 times negative 3, and we're hoping, if it were true, that that is greater than or equal to 6. But we are already pretty sure from the picture that it's not. So 2 times 2 is 4. 3 times negative 3 is negative 9. And so we're going to get negative 5. Is that greater than or equal to 6? No, because negative numbers can't be bigger than positive numbers. And so if it fails in the first inequality, we don't really have to check the second one. So up here where my answers are, I'm going to X that out. Just like we would on the park assessment next week with your strikeout tool. Friday, charged iPads, going over the tools, make sure. So X, but that's one of our tools, is to cross out if it was multiple choice. Or if it was one of those where you could do multiple answers, we at least know that one doesn't work, and we've already checked it, and we've got it on our paper. And on your scratch paper, you may want to mark, what it was too. So do they label them A, B, C? I don't know if they do. It may just be listed. So, all right. So let's look at the next one. Negative 1, negative 2. So I'm starting here, going left 1, down 2. Does that look like it's going to be a solution the way we have it graphed? No. So we're thinking no, but let's check for sure. So I'm going to put B over here. I always just start with the first inequality. If it passes that one, then we check the second. So we'll do 2 times negative 1. Plus 3 times negative 2. And we're hoping, if this works, that it's greater than or equal to 6. So I'll just go ahead and put that over there. So this didn't work. I should have like striked that out. So 2 times negative 1 gives me what? Negative 2. 3 times negative 2 is negative 6. Okay, so if I add negative 2 and negative 6, what do I get?
Negative 8.
Okay, so negative 8, also not going to be bigger than negative 6 or equal to negative 6. Doesn't work. So we're going to cross out B. Not a solution. Doesn't work. Okay, let's look at C. Negative 3, 6. So I'm going to look at the picture first. Start the origin. Where do I go for negative 3, 6?
Left 3.
Left 3, and then
Left 6.
up 6. Good. So 1, 2, 3, 4, 5, 6. It's looking like it's in our solution region. So that's just, in my mind, when I test it, I'm thinking it should work in both inequalities. So we're going to try it. So come down here where our work area is on C. We're going to put in negative 3 and 6. Negative 3 is X. 6 is Y. So 2 times negative 3 plus 3 times 6. All right, so somebody besides Jillian and Gabe volunteer to help me out. What's 2 times negative 3? Good job. And what is 3 times 6?
12. No, 18.
18. Good job. It's okay. When you're on the spot, sometimes that just happens. I do that all the time to you guys, and you guys are like, no, wait.
Well, the answer is 12.
That's true. The answer is 12. So maybe you were just a step ahead. So negative 6 plus 18 is 12. And oh, lo and behold, that is greater than or equal to 6. It's actually greater than 6. If it works in the first inequality, it's just like systems of equations. What that means is it works with the first one we graph. That means it's in the blue, the first solution region. But it may or may not be in the second one. So we have to test by putting it into the second inequality right here, the x minus 2y. Let me just zoom out so you can see a little bit more. X minus 2y is less than 2. So x is negative 3. Minus 2y is 2 times 6. And we're going to see if that's less than 2. So we're going to do 2 times 6 first. So it's going to give us that minus 12 there. If I have negative 3 minus 12, we can also think of it as negative 3 plus negative 12. So basically, we're just adding 3 and 12 together. I was like, what's 3 and 12?
What?
What's 3 and 12?
Adding them?
Adding
15.
them. 15. And if there's a negative in front of both of them,
You
then
mean negative 15?
negative 15. Good job. So negative 15 is less than 2. Is that true?
No.
Yes.
Yes, because this is a
wait.
negative. So think about your number line. Anything to the left on the number line would be less than. So it does work. So C up here, we're going to circle that. If this were your park test, you would click that one because that would be your answer. But this is a multiple solution one. There's going to be more than one that works. So let's go over to D. So D says 5, 1. So if I'm starting at the origin, where is 5, 1?
Right 5 up 1.
Right 5 and up 1. So I look like I'm in the blue, but not the red and the blue. So what's looking like is it's probably going to work on the first one, but not the second one. So if I wanted to save myself some time, just do the second one, save us a little bit of time, because if it fails one, it fails the whole thing, right? So D is X and Y. So we're just going to try it in the second one. I know, I'm trying to keep this big enough so you guys can see it, but then, so we're looking at this inequality. So we're doing D. I'm going to label that down here. And so X is 5 minus 2y is 2 times 1. Checking to see if that's greater than or equal to 2. So 2 times 1
It's less than.
it's less than. I'm so sorry. See, I told you I make mistakes all the time. Less than 2. I was looking at the other one and I copied that down. Okay, so 5 minus 2 times 1. What's 2 times 1? 2. So it's basically 5 minus 2 would be 3. Is that less than 2?
Absolutely not.
No. So by just doing the second one, kind of looking at the picture, thinking about it a little bit, we know that that one's not going to work. So we can kind of strike that out. We know that doesn't actually work. It's not actually less than. And we can cross off D up here. It didn't work. Okay, let's do E. 2, 5. So 2, 5, we're going to go right to and up 1, 2, 3, 4, 5. Does it look like it's going to be in the solution?
Yes.
Yeah, it looks like it's in the red and the blue. So we're expecting that it works in both. If I did this and it didn't work on both, what would I know about my graph?
Then
It's probably not right. I might want to start over. I might want to go back to where I graphed and do the shading again and make sure I rearranged again. Like if we thought, so if this was something that we knew should be a solution, then yeah, you might know that it wasn't. Okay. Anyway, E. So I'm going to do E right here. We have 2, 5. 2 is X and 5 is Y. And so we think it's going to work on both, so we have to test both. So starting with the 2X plus 3Y, we'll have 2 times 2 plus 3 times 5 greater than or equal to 6. We'll try that one first. Sure looks like it's going to be bigger than 6, huh?
yeah.
So 2 times 2 is 4. 3 times 5 is 15. Doing our order of operations here, so 4 times 15, or 4 plus 15, I should say, is 19. It does look like it works for the first one because 19 comes out bigger than 6, which is what we expected. Sorry, I just went off the screen. I'll pause for a second because you probably couldn't see what I was doing. Okay, so we got 19 greater than or equal to 6. That checks out. Then we've got to do the same thing with the second inequality, which is the x minus 2y is less than 2. So x would be 2. So write that down. Minus 5. 2 times...
Minus
2 times 5, I'm getting flustered, is less than 2. Did I make any more mistakes?
No.
No. Thank you for watching. You gotta watch me. All right, so we'll have 2 minus 2 times 5 would be 10. What happens if I take 2 minus 10? Negative 8 is less than 2. Does that work?
Yeah.
Yes.
Yes, so it worked on both. It looks like it works on the graph. So if I went through and for some reason it didn't work on one of these inequalities, but it did look like it worked on the graph, then I would have to go back and rethink my graph. And so this is how you can use test points. I'm sort of killing several birds with one stone here by looking at these as just sort of a multiple choice problem. But it also helps you kind of rethink, okay, if I'm checking it this way, it looked like it worked on my graph, then I know I probably didn't do something right. Okay, there's one more for this problem. There's a reason we're not going to do 10 of these because they take a while. And it's negative 5, 4. So let's start at the origin. Where do I go to do the negative 5?
Left
5, up 4. I said it. And so it's right there. So it looks like it probably works on the red one, which was the second one, right? So if I wanted to test and think it's not going to work, I want to try the one that was blue, which was the first one that we tried. So let's plug it into the first one and see what happens. So negative 5 is x, and 4 is y. Here's the inequality we're looking at. 2x plus 3y is greater than or equal to 6. And it's kind of hard to get all of this on the screen at the same time, but you guys are good. You know what we're doing. So down here on f, we'll have 2 times negative 5 plus 3 times 4, and we're trying to see if it's greater than or equal to 6. All right, let's do the math. 2 times negative 5, I feel like we've done several times. Negative 10, good job. And 3 times 4 is 12. And if I take negative 10 plus 12, it's 2. Is that going to be greater than or equal to 6? No. So automatically I know that doesn't work. I know this is not one of my solutions. And we think we've got it. Okay, so systems of inequalities, we graph them and shade them just like we did when there was only one, but you can have 2 or more. We want the solution to be where it all overlaps. We're going to start the next one together, and then you guys are going to finish it as your practice problem. This one has some different things in it that we did talk about in the last lesson, which we did on Friday, and then you guys reviewed yesterday. Some of these are special lines. So, for example, if I have y is just greater than negative 2, there's no x's in there.
Oh, that's horizontal.
It is horizontal, and it will go through the y-axis at negative 2. Now, dashed or solid? Dashed. So I should use a ruler, but since there's a line there, I'm just going to kind of draw it in there. Make it kind of fat so you can see the dashed. All right, dashed line. And then it's greater than. So where are the y values that are greater than -2? Would they be above the line or below the line?
Above.
Above the line. Good job. So I'm going to shade that one. I'm going to use blue. So we're going to shade above the line. And so that's where all the y values live that are bigger than -2. Because you have -1, 0, 1, 2, 3, 4. All those positive numbers and a little bit of negative numbers, all are bigger than -2. You want to shade lightly because we have to do 3 of these all in the same graph. I should have said that in the beginning. All right. The good news is we didn't have to rearrange that one. Yay. Okay, so what happens if I just have x is less than 3? First of all, what is that line going to look like? Good job. Vertical at 3. So you go to the x-axis to 3. Put a vertical line right there. Dashed or solid? Good. Glad you guys reviewed this yesterday while I was gone. So you're doing great with remembering all these details. And I'm having a hard time drawing a dashed line, but we're just going to pretend that that looks perfect. All right, now, these are the ones that I think are a little tricky. We need to think about where the x values live that would be smaller than 3. So on this side I have 4, 5, 6. On this side I have 2, 1. Where are the numbers that if I put them in here for x would be smaller than 3?
Left side.
The left side. Okay? So you have to think a little bit on those. It's not quite as easy, but you think about the x-axis as just being a number line because it is. And where those x values are that would work in here. Well, 2 would work in there if I put it in. 2 is less than 3. 1 is less than 3. It's got to be this side. Okay, so I'm going to shade that side very lightly with red because I couldn't find my pink. Kind of sad about that. Somebody borrowed my pink and didn't give it back. Story of my whole teaching career. All right, so now we have a start on our solution region over here where the blue crosses the red and kind of makes sort of a purpley section, or whatever colors you're using. It may have made a different color. We still have one more. You can have a lot of different lines, and you get into the story problems later. Sometimes you'll have 4 or 5 or 6 different lines, and you get to make little shapes. It's kind of exciting. And so this is our last line. What do I need to do to this before we can graph it?
Rearrange it.
Rearrange it. You guys remember the song? You want to sing it? The x term divided by the coefficient of y. All right. We love this song. They love it. Okay. So we're going to add or subtract the x term. Do we add or subtract? Subtract because it's positive. So I'm just going to do that down here. Since there's only one of them, I'm just going to do it below. Save a little space. So subtract the x term. And then when we rewrite it, what's it going to look like?
Negative y is
Greater than or equal to, yes.
negative x minus 1.
Negative x minus 1. You could do negative 1 minus x if you can keep track that the slope is of the x, but a lot of us like to do it in this order just so it's always the same. Okay, so I have the negative in front of y. What number is implied there?
1.
1, negative 1. So what do I need to do with that?
Divide.
Divide by the coefficient of y. So we're going to divide by negative 1 on everything. Okay? And we're dividing by a negative again. So alarm bells should be going off in your head. What do we have to remember to do?
Flip the sign.
Flip. So we're going to bring this down to go, whoop, goes the other way. So we now have y is less than or equal to, and we get to figure all of this out. So yeah, this is going to be negative 1x, and negative 1 divided by negative 1 is positive 1. If you want to write 1x or x, either way. I heard Gabe say x. You can do it either way. Some people still like to see the 1, just to think about it. And then negative 1 divided by negative 1 again would just be 1. Okay, so we've got it rearranged. And where are we going to start the line? Positive 1. So on the y-axis, positive 1, put a point. And you've shaded twice up there, so you want to make that dark so you can see it. Dark and bold. And then if I have a slope of 1, where do I go from there?
Up 1 over 1.
Up 1 over 1, up 1 over 1, up 1 over 1. I want to keep going with that out a ways. And I also want to go this direction. Down 1, back 1, down 1, back 1, reverse. And take that out a ways. Get all of our points. You may have to make them really dark to stand out over your coloring. All right, so is this line solid or dashed?
solid.
How do we know?
Because there's the equal.
It's got the equal to line. That means that the solutions, we could have solutions that are on this solid line, not on the other two lines because they were dashed. But anything that's on this line could be part of my solution. You know what I forgot? I forgot to put arrows in all my lines.
Oh no.
So I'm going to do that really quick. All right. So with the shortcut that we talked about, we're looking for y values. We already did the equal to, that's the line. We're looking for now to shade the y values that are going to be smaller than what's on that line. So from this line, the y values that are smaller than what's on this line would be above or below? Below. Because with the y-axis, the numbers that are down are smaller. And that was sort of our shortcut that we talked about. I'm going to see if, I don't know if yellow's, let me use green. And so we're going to shade below the line because that's where the y values live that are smaller than what's on the line, would be below because y values go up and down. So it gets a little messy when you get all of the colors overlapping. Something that I have had students tell me really helps them sort of focus is to take their pencil and just kind of shade in really dark where everything crosses. We happen to get a triangle this time. We made a shape. Yay. Just be careful that you can still see that this is a dashed line and that's a dashed line. I kind of tried to make mine really fat and bold.
And the
In this one.
coordinate, the grids,
Yeah.
the squares.
Yeah. Yeah, it is nice to still be able to see the little grid underneath. That's true. So maybe you don't want to color it in. Like I had somebody take a Sharpie and darken it, and I'm like, now you can't tell where the points are. But they could still use the grid around it. So I was okay with it. I mean, just kind of helps us focus. So what we're going to do with this now is I'm going to turn this over to you guys. And you have 6 points down here. And I want you to test them down here in all of this space and see if they're part of our solution region up here. And then we're going to check at the end. And when you've got it all good, then I will give you the assignment. Okay? So you're going to test these, showing me all of your lovely work. We left lots of space on this page. And then we'll check them.